Hi guys, my name is Abdurrahman Gilal, and in this video I'm going to explain you how to search an element from an array. So we know that we may have an array that is of maybe million numbers, or let's say 100,000 numbers. So it is always a good way to know that how can we efficiently search. So the first and the basic search that happens is the search that we do with like simple if statement, and we traverse all the elements of the array, and that's what we call linear search. So linear search is very pretty straightforward. For instance, this is my array, and this array is basically having these numbers, many numbers, and then this is your target that you want to search. For example, you have this target as, let's say, 2 you wanted to search. So what happens actually, this goes after every element of array and try to see like if the element meets with the element of array. So if it finds, and then it's up to you. You wanted to manipulate any information up there, or you wanted to return an index. But as we know that indexes of array always start from 0, 1, 2, 3, 4. These are the indices, right? So basically when the element is not found, it returns us nothing, or we can make a logic like, well, like let's say we return, let's say -1, which means we did not find. Why we said -1? Because we know that array indices always start from 0. So there's never a negative number. So this search is very pretty straightforward search if we know how to access the element of the array, and then we just apply a statement. So this could happen with the loop, and this could happen with the if statement, and that's it. But there is a one flaw in it, that we have to traverse all the numbers of element array. So if the elements of array are, let's say, few, that's quicker. But what if the array elements are 1 million? That's gonna be, a big challenge for us to manage. So that's like we're pretty straightforward. A lot of, developers do not prefer linear search if the size of array is longer, let's say until 1 million, or could be more than 1 million. So we have a lot of restrictions in programming languages sometimes when we are using these recursions. So it is Stack Overflow can happen, and then the program may be slow to find out the element. So there is another type of search, that is a binary search. So what binary search does, that it basically divides the let's say the same array, 1, 5, 1, 3, 6, and 7. So it does few things. The first thing it does, it sorts the elements. So why do we do that? Because if we do not sort the elements, it's gonna be like not easy for us to find out where exactly is our element. So if we sort out, we know that the smallest values are like in the beginning, and the largest value are the later, so we can go there at the midpoint. So the first point is that, and the second one is to know low and high indexes. So low and high indexes, which means that for time being, this is our low index and this is our high index. Based on low and high index, we identify the middle index, which means that what is a center point. So this is a center point. Why do we do that? Because we wanted to start search from here. So the first point is to sort the elements, sort the array, and then the low and high. It is pretty straightforward in the beginning, but because we always have the first element starts from 0, or the last element is the array dot length -1, which is pretty straightforward. But that's not pretty straightforward when you are already into the execution and into the search. So you have to have a logic by which you will set up either low or high indexes. I'll be explaining shortly after this video. No, sorry, after this explanation. Okay, so but for the sorting, I have another video available. You may gonna go and look on it if you are interested. Otherwise, we are using in this video, we gotta use a arrays dot sort. This is the available method in the arrays class in the arrays library. So it's up to you. Like if you wanted to just use this one, this is gonna basically work on quicksort, and quicksort is the fastest sort so far known by the programmer, if I'm not mistaken. So let's say, so if the first element, let's say we were trying to search, let's say 1 from here, this was our target, and then this will be going and comparing, and we're going to see like if the 3 equals to 1. If that's the case, then we return. But if it's not the case, then what we do is that we try to see like if the element, like this target element, is smaller or bigger. If the target element is smaller, then we go this side. and we eliminate this whole. That's one of the beauty. That's why we say binary, which means we divide, right? And if the element is bigger, for instance, the element was 7, so it will go this way. So, and that's pretty straightforward that we eliminate these all elements which are on the left. So let's say if you had a 1 million elements and then your center point was, let's say, 500,000, and then the element was one was smaller, so you eliminated 500,000, 500,000 records in a one pretty straightforward go. Only thing that you had to do is to basically do the sorting first. If not, then how are you going to know that which element you are going to drop? So that's pretty straightforward explanation about linear search and binary search. So there are a lot of benefits of using binary search. It's like pretty straightforward. Like it's good for large scale, search space. So you should be using binary search. And if you have a small space, then you may use the linear search. Linear search does not have any sorting, which means it's also having another computation. Sorting does not happen without computation. So that's why if you have a small scale of search, so it's better that you use linear search. But if you have a larger scale, definitely you do not occupy too much space or complexity just sorting an element because you're saving 500,000 elements in one search. So this is like everything has its own benefits, pros and cons. So I'm going to explain you both. It's pretty straightforward here. Please do not hesitate to drop me a comment if you have any confusion. So I have already set up my basic, program. I have already imported this arrays library and then random. Why I'm going to take random? Because I'm going to assign the elements to my array randomly from 1 to 10, or sorry, 0 to 10. And then I have set the size of my array is 7. So it's like quite reasonable size. I'm gonna go like it could be increased, but I just made it 7 for us to understand it better. And then I'm just gonna print like the array, so arrays dot to string to see like if the elements of array are there or not. And then I'm gonna make this two methods. One's called linear search and one's called binary search. I've not done anything yet in both of them. Yeah, so this is what I'm gonna do. So left click, right click, and then go and then create a method. So if you want to make it public or private, it's up to you. I'm gonna make it public. Okay, so first thing is that we have already received this complete array from the caller and then the target that we wanted to search. As I told you that the first thing we have to do is to just simply run the overall loop to see like if the overall space overall elements in the array. So I'm gonna say like, okay, so what should be the uh, you know length that until when I'll be searching. Definitely, I'll have to search until the end. That's one of the drawback. So I will be searching every element. So the first thing will happen is that I have now to search that array, which is I am trying to look for, has a value that is target, let's say. If yes, then return the index. So what should be the index? The index should be I. That's pretty straightforward. If we did not find any element throughout all the loop until here, so what we're going to do is that we return -1, which means we did not find. So both of them will be sent back here if element was found or if element was not found. So far we have used a random class, so we don't know will that particular 5 target will be there in the not in the array list or not. So but let's say for the time being we're gonna do that. So let me just stop this first here, try to run this like if it works fine. So yeah. Okay, this is my bad. I was supposed to. Okay, so let's run it again. Okay, so you see the elements that came basically were like 1 8 5 0 8 7 3 7. So here I had to print it out, which I didn't print. So let's run it now. If I wanted to print like, so first thing is that I have to check this element that whether this has result if it's greater than or equals to 0, which means we definitely had found the the element. So we found your desired targeted element, let's say at position or index. It's up to you. You're gonna put like linear search results. If not, then we're gonna simply say, sorry, you do not have your targeted element in the array. That's just a logic. Let's run it. Yeah, so let's say our target is 5. We knew that, so keep searching it, and we're gonna see like if we can find out somewhere. Yeah. Oh, okay. So this is number 5, and we found at the position number 4. That's true. 0, 1, 2, 3, 4. That's 3. So that's very quick enough. And then now we're gonna go for the uh, how to say for the binary search. We knew that we have to do the first is the sorting. If we do not do the sorting, it's not gonna basically work with the binary search. So the first thing that we have to do is sorting. So as I applied arrays.sort method, let's run it and see like, so you see this array is sorted now. Previous array is not sorted, but this one is sorted. That's pretty straightforward. And now if I wanted to make this method, so let's create this method. If you wanted to make it private or public, it's up to you. I'm just gonna make it public so that everybody can use it. Sorry, yeah. So now here is something like we discussed. You remember we have to have lower, higher, and middle values. So the first thing we have to make a variables that will actually help us to keep the lower and higher. So we know that higher is always the length minus 1 because length will return as the overall element, but indexes do not start from as per the number of elements. For example, this array has 0, 1, 2, 3, 4, 5, 6 indices, but total 7 elements. So that's why we have to do minus 1 in order to be accessing it nicely. And now we also have to do this, you know, check because we will be dividing the list or array every time. So we have to make sure that the lower and higher are always not matching and reaching in one place. As soon as they reach in one place, that means they are not. Let's say lower will be reducing towards the higher, or higher will be lower will be increasing towards the higher, or higher will be reducing toward the lower. We can understand shortly. So our first thing is that we have to make sure the low is always less than or equals to high. If that's the case, then we run this. So now we have to start to compute the midpoint. So as soon as we go there, so we have two ways to compute. Like one is that we add high plus low divided by 2, which means the average. But sometimes when you have even number of elements in the array, so it does not give an accurate answer. So basically this one is going to give you accurate answer for all the type of how to say computation if your array is even an odd elements. So what is going to happen? Let me quickly write for you. Okay, so let's say I have said like low, high, and low. So right now low is 0 and high is minus 1, which means 6. So we're gonna say 0 plus 6 minus 0 divided by 2. So this is going to return us 3 plus 0, which is going to be 3. So now our midpoint is 3, right? So this is the same thing gonna happen in the next computation. I'll be explaining you that this is gonna be the ones and that we gotta use it forever. So this is all. This is all. And then once we have the index, so what we have to do is to make sure that the mid, the center point, the center element is equals to the target element. Because we already knew that the center element, if it's with the target that we are trying to search, that's it. We found the center point, but that's not gonna happen. Let's say right here, for instance, we have 5. So we found it at the center point. So if we found it, so what we do is that we just return the index, which is middle index. This is also possible that we did not find at the center point. So now first thing we have to do is to make sure to understand whether the element is smaller or larger than the target one. So let's say I'm going to say element that we are looking at right now is smaller or bigger. So what will happen here? We have to say mid plus one. Why I'm gonna explain you like this way. Okay, okay, good. So let's say this is the element. Let's say for example, we have this array mid and this. So right now array mid is 3 and this is our elements like 7. So this is our 1, 3, 4. So this is our element. We are trying to search 5. So this is saying like 7. This is the element less than 5. Is it true? That's not true. If that's not true, which means the element is basically smaller than the number 7, right? Because we are trying to say 7 is smaller. So 7 is not smaller. So if 7 is not smaller, so we eliminate all these 888s. Now we are gonna go like here. How are we gonna go there? So we're gonna go. Okay, so I'll give you a second. I'm sorry, like I am making a little bit confusion here. Okay, so we're gonna say like if the element here, which is mid right now, it's our 7. 7 is less than target element is 5. So we're gonna simply say mid plus 1. But that's not the case. That's not working. So if not working, so this is not gonna happen. So what we're gonna happen is now we have to make another logic, which means that we have to give me a second. Let me clean this. This is screen is a bit messy. Yeah. Yeah. So if this is not a case, then what we're gonna do is that we're gonna simply say high equals to mid minus 1. That's our logic. So why it happens, once again I told you, we knew that our element is, yeah, here. This element right now is 7. Is 7 less than 5? That's not true. It's not working. So this is going to work. So high has to be changed. So right now high is, let's say high is 7. High was 7 because we started at a 7. So now mid is 3 because we found that this is the midpoint. So 3 was the index. So now high will be mid minus 1. So now if you see here, mid is 3. So 3 minus 1 is basically going to be 2. So now you see here 0, 1, and 2. So this is going to be the high point, which means that we start from 0, but the high point is now 2. So the high is 2 and the low is 0. So now you remember the previous formula. You remember this previous formula. This one. Okay, excuse me. Yeah, you have this one. The now high is 2, low is same 0, and now we have to compute mid. So now compute the mid. So it is low is 0 plus 2 minus 0 divided by 2. So it's gonna be 0 plus 1. So now mid is 1. That's pretty straightforward. So the next time it comes back here and try to search if the mid is like let's say an element is 3 equals to 5. That's not the case. So if it's not the case, then it's gonna go further down and then gonna check it like if the mid is like right now we have 3, this number, this one is less than 5. That's true. So now it has to go back, but we do not have any further element there. So we will not be able to find out. This is how it works. So I hope it makes some sense and let's run it. So now if it did not happen, then what we're going to do is that we just simply return -1 after everything is done in the while. So now same thing here that we have to search. We have this element, this binary search. We try to search and then we put this binary number. So let's say if we say if binary return has binary result has got more than 0 or 0, that's what we found. If not, then we didn't. So you're gonna see we did not find in both. We did not find, yeah. So here you see this was 0 index because this is unsorted element. So the index, but in the binary search we found out here at third position, 0, 1, 2, 3. This is true. I think this is all about binary search, but if you wanted to know that do we have any other predefined method available? Yes, arrays library also gives us this binary search, which means that you have to just pass the how to say pass the array and then the target. So this is going to help you, and then you're gonna find out the same thing that you try to like find out. So it also helps you. Oops. Yeah. So it is also going to tell you that if you can find out the element. So it's -1, which means it didn't find out. So same thing. You found out a 3 index in the 3 index. Here I did not use any if statements. If I would have used the statements, it could have been given us the same results. Let me do it quickly for you. Like if I'm working on arrays, binary search, and I pass the array and I pass the target. So you already have something available, integer temporary I'm working on right now, and I'm gonna just do the same thing, exactly same thing here. The stamp I'm using, the stamp I'm using. This is from predefined binary search method. So we gotta see like, is there any difference? So yes, it's from predefined method, the same 5 index and same 5 index. So we have developed exactly the same predefined method that is a binary search. Why I did it explain because I thought to as a computer science student you should be knowing that how exactly it is working from inside. But if you think that you already know, then you may be using this arrays.binary method from the arrays library. Yeah, from here. So if you have any other question that you want to know, please do not hesitate to drop me the comment. Take care, please.